my name is Arreola.
I'm Luis Jimenez.
And my name is Fernandez. And we're engineering students from the University of Texas at El Paso. And today we're going to be teaching you how to build your own trash sorter with TI technology.
So now in this video, we will show you how to build the prototype. Now in this table, you can see all the parts needed for you to build the prototype. Right here, we have the two bases that are going to be needed for you to make the full base. Now, you're going to connect it by using a nut and screw, and this is how you're going to connect it. Just like this. Now we're going to use the rails, which are going to be used as support for right now your base. And this is how you're going to put it. In each corner, between 1, 2, 3, 4 holes, you're going to put it. And then I put the screw, and under it, the nut. We're going to do the second one on the other side. Now I'm gonna go ahead and place the plate on the top. I would suggest leaving 2 spaces alone so you can keep putting the rest of the parts. So if you can see here, I put it in the middle, or the third hole, and this is where I'm putting the screw and the bolt. Once this is done, we'll go ahead and continue with the gussets. Now, these are known as the gusset pack. There's still more. But these main ones, we're going to put those 2, just like this. And you're going to measure it with a C-channel. This is going to determine how much space you're going to leave. So if you can see here, I'm measuring where I'm going to put my screws and my nuts. So now after this part, I'm gonna go ahead and measure it again and grab off my other nuts. So just like this, make sure to leave the corners close to the gussets. So now that I know where I'm gonna put my screw and my nut. Now that I have this part done, I'm gonna go ahead in the first hole of my C-channel. I'm gonna put a screw that is gonna be connected with the gusset together. This is gonna help me to connect my 2 pieces, for example, such as joints, and it's gonna facilitate it for me in order to move the C-channel up or down. So if you can see here now, I created sort of an angle between what's the height of the rail and the C-channel. And now I'm gonna put another screw to the other side. This is to make it stronger and tighter so my C-channel won't be moving around. Now once it's tightened enough, I'm gonna go ahead and move with the other part. Now in order to attach this little C-channel, I have to use my gussets, which I'll use at the end of my C-channel. So we're gonna put one of my screws through, not the hole, but the whole like happy face kind of looking part. And that's how you're gonna put it. Okay, that's set up. Now I'm gonna put the other side. This is also to facilitate the movement of the little C-channel, and it's as well a part used to connect the pieces, such as joints, like I said before. And this is how it's gonna look. So you place it, you grab your screws, and we put one to each side. Now, you don't want to leave a lot of space between the C-channel and the little C-channel, because then your trash is gonna fall through there. So right now I'll show you how I'm gonna push it up. So then, because of that line that we have with the screws and bolts, you're able to move it forward or backward. So it facilitates it for you. Now we're gonna add another rail. This is gonna help you for your support with the motors. So for example, right now I will show you. I need to see how many holes I need to put my rail into. So I have to measure by using my motor. Now in this part, you can see the motor. This is how we're gonna place it. Now you can see I'm measuring how tall should I place it according to my C-channels. And that's the hole that we're gonna put it in. So 1, 2, 3. And then middle road. And we place our screw. Now that you have that set up, you tighten it more, because this is an important part that needs to be able to not move at all. Now we're gonna put the motor. This motor includes an attachment of a gear. This is bigger because we wanted it to be more flexible. Now inside we have a little attach, which is for the big gear, and you're gonna need it for it to be placed. Now we also glued that 4 bar to the gear in order for it to make like a little door when the trash is being dropped. You'll see right now. And this is another bar of 2, which we will use to connect the motor to the rail. Now if you can see here, I'm placing the bar according to the height I want my motor to be. So we're gonna measure again. That's perfect, close to the C-channel. And then I'm gonna put my bar where I want it to be. Now this bar is just gonna hold the piece. If you can see right there with that blue part of the motor, it's just gonna hold it in. So I'm gonna place my screws right now. And not only one, but I'm putting 2. That's the reason for the bar to have 2 holes. And I'm not tightening it yet, because I'm placing my second one and I'm also leaving a space for my motor to go in between the rail and the bar. So you can see here I'm putting in the nut, but I'm not making it fully tight. Now I'm able to, when I want to pull the bar, I still have some space in between. Just like this. Now you put the motor in there, and with your wrench, you're gonna tighten it as hard as you can. This is to help it be strong and not be able to fall between the motor and the rail. You can see it here? Perfect. So this is how it's gonna look with your motor on. And remember that the little bar that the gear has on, it's gonna be as a door for your sear channels, okay? Now we're gonna put this part. If you can see, this is an 8 space hole bar that it's gonna include a motor which is glued, or it can be tape as well. This is just using our resources as the best we could. So if you can see here, we're gonna put it in the middle of the square. Again, it's an 8 hole bar. So right now we'll put it in the middle of the square. This is where your screw goes, in the middle. So 1, 2, 3, and 1, 2, 3. This is to give it movement between, which is the motor and the sear channel. You can see I'm moving it. Now we screw it with the nut. Now that we have this part, I'm gonna make it tighter. I want this bar to not be so flexible, but also to be able to move. Just like this. You see it? That's strong. Now, this is where your creativity goes in. We created this plate that it's gonna separate your trash in 3 different parts. In the back, we have attached a gear, which is gonna go with the motor at the bottom, and this is how we're gonna place it. So once you put it with the gear and your motor, you can move it backwards or forwards, and this is how it's gonna separate your trash. And this is the end of the first portion of the video. Now my partner will explain you furthermore into the programming. Enjoy!
Now here we have the calculators, and we're gonna plug them into the hub, as you can see right here. First, we need the cable that has the AB connection, as you can see right there. Then the A goes to the calculator on top, and the B will go to the hub, just like this. And then we're gonna repeat the same for the next calculator. Again, port A on the top of the calculator, and port B into the data port on the Innovator Hub. And now, since we're gonna use the servo motors, we need more power to the hub. So that's why we're gonna connect them into the light. So we're gonna connect the cables to the power output of the hub. Now we're gonna connect our light sensor and our servo motor on the same hub, because those are the ones that are gonna communicate. So for our light sensor has to go into input 1, as you see right here, connected. And now that we connected our light sensor 1 into input 1, we have to connect our servo to out 3. And this is very important because the servo won't be able to work unless it's operating on the 5-volt part of the servo, of the hub. And again, we're gonna connect this top servo to another hub, and that's your setup. Now we're gonna explain the code of how the servo and the light sensor work. Here we are using the TI-Inspire CX teacher software, but if you're using the student software, it's also the same, not very different. Now, the first thing we need to do is define our program. In this case, we're gonna name it Innovator Light Sensor. Now, we have to, as you saw before, we connected the light sensor into the in1 of the hub. So now we have to give an instruction to a calculator so the calculator knows that you connected the light level into the input 1 from the hub. Now we're gonna then create a for loop, which is gonna go through it 3 times. Then inside the for loop, what we're gonna do is we can send an instruction to the hub so it can get the light level from the light sensor of each object. Then we're gonna store that number or that information into our variable I, which then is gonna display it so you can see it on the calculator. So then you can use those numbers on the final part of the trash sorter. Now we're gonna explain the servo code, and here again we need to define our code, and it's gonna be in the innovator servo. So then we're gonna send a command that's gonna say to the hub that we connected a servo motor into the output 3. For this, it's very important to put output 3 because, as I mentioned before, the servo only works with 5 volts, and that's given from the output 3. Now we're gonna send an instruction that's gonna set the servo 1 to 90 degrees, which the 90 degrees will turn the servo motor counterclockwise. And then we're gonna wait a second so you can see how it rotates, and then we're gonna do the same but doing the negative 90 degrees so you can see how it rotates clockwise. Finally, for our last code, we're gonna add all together, which is the servo and the light sensor, so it can work. So again, we need to define, in this case, we named it recycle system. So again, as on the previous examples, we need to send instruction to connect the light level 1 into input 1 or whichever input you want, or connect servo 1 to the output 3. Again, 5 volts, very important. If not, it's not gonna work. The next instruction is gonna be read the light level in input 1. Then we're gonna get that I. We're gonna wait a second and a half just so the top servo can open the gate. Now here we have a series of if statements that, depending on the values you got from your light sensor code, it's gonna determine the ranges for your materials. So for example, here this could be aluminum, and then depending on that, since we have a plate with 3 divisions, you will set the servo to rotate a certain degrees for each material, and then it's gonna display again the value you get for the light level, so you can see if the value was correct or if it was supposed to be correct. Then it's gonna wait 2 seconds to come back to the original position, and that's why we have this. So as you can see, we rotate 90 so that trash can fall in the correct bin, and then it's gonna rotate negative 90 to come to the original place. So then the second object could start its processing. And then after all, we're gonna end the if, and that will end the program.
Okay, now that we have everything plugged in, we can see how the light sensor is gonna get a reading, and according to that reading, it's gonna rotate the motor on the bottom to rotate our plate to allow the trash to fall in the correct bin. And the other servo, it's allowing the trash to fall into the bin. Thank you for watching our video. Now that you know how we built our own trash sorter, we're gonna challenge you to build your own.
Now please go like the video in the button below and let us know what you think in the comments. Also, we have attached a link for you in case you want the CAD files or if you want to know how we 3D printed these parts.